Okay, there are just a couple things I want to point out on this page before we move on. We already talked about how ln of x means log base e of x. And not that we care, but it's derived from this Latin phrase, logarithmus naturalis. So y equals the natural log of x if and only if x equals e to the y. And then here you have the graphs. The e to the x is the top one, and ln of x is its inverse, which is below it. And you see they've drawn this y equals x line through here, because if you flip y equals e to the x over the line y equals x, that's how you get the natural log. And that's true for all inverse functions. The other thing I want to point out is the common logarithm. So if you see a log, log, with no base, that means log base 10. So y equals log of x if and only if x equals 10 to the y. And they've graphed both of those here for you. They're just like all the other exponentials and all the other logs. And again, they have put in this line y equals x because if you reflect across that line, that's how you come up with the inverse function. So moving on to the next page. Okay, so how do we graph these things? Well, it's not too bad. If we need log 2 of x plus 1 minus 2, by doing our transformations, we have a vertical shift down 2, and we have a horizontal shift left 1. So we could, wow, this is a terrible looking graph. We know the point 1, 0 is on the graph of any logarithmic function. So if we shift that left 1 and down 2, we are at the point 0, negative 2. Okay, we can just plot points if you want also. That might even be easier. So, if we have a normal log of 2, base 2, if x is 2, y is 1, so if we shift that, so let's see, x is 2, y is 1, we would shift that left 1 and down 2. I feel like I've gotten that in the wrong spot. Let's see. Nope, that's where it goes. My bad. So we've got something that looks like this, more or less. Now, this time, you'll notice we had a horizontal shift left 1. So our vertical asymptote moved from x equals 0 to x equals negative 1. Okay, how about 1 minus log base 2 of x? Well, if we rewrite that, That's negative log base 2 of x plus 1. So we have a reflection across the x-axis, and we have a vertical shift up 1. So our point 1, 0, when we reflect it across the x-axis, since it's on the x-axis, it doesn't move, but then we have to shift it up 1. And before, our function went sort of like this, so when we reflect it, it's going to come down. So this one is log base 2 of x, and when we reflect it and shift it up 1, it goes like that. And we still have a vertical asymptote at x equals 0. And this one is our log base 2 of x plus 1. Okay, moving on to the next page. How do we solve basic logarithmic equations? Well, first you have to isolate the logarithm and then change the logarithm to exponential form, and then it's just like what we did in the last section. So if we look at part A, we have log base 2 of the quantity 2x plus 1 equals 3. So 2 cubed equals 2x plus 1. Well, 2 cubed is 8, and that equals 2x plus 1. So 7 equals 2x, which means x equals 7 halves. And of course, you should always plug back in and check. On part B, we have x cubed equals 343. Well, 343 happens to be 7 cubed. If the exponents are the same, then the bases better be the same. So x equals 7. Part C, we have to isolate the logarithm first. So we have negative log base 10 of x equals negative 3. So log of x equals positive 3. So 10 cubed equals x, which means x is 1000. Remember, if there's no base with the logarithm, it's base 10. Okay, on part D, that's a natural log. So that means the base is e. So we have e to the 5th equals 2x, or x equals e to the 5th over 2, which we could plug in our calculator and get an approximation if we wanted to. Okay, on part E, again, it's a natural log, so e squared equals x, and we're done. On F, we have 6 raised to the 5x plus 3 power equals 36. Well, 36, is 6 squared. So 6 to the 5x plus 3 equals 6 squared. 5x plus 3 then has to equal 2, which means 5x equals negative 1, so x is negative 1/5. And again, we need to check. Okay, scrolling down to the next page, we have log of e to the x equals 8. So that means e to the 8 equals e to the x. So x has to equal 8. Part H, we have 10 to the x equals 1,000. So 10 to the x, 1,000 is 10 cubed, so x equals 3. And I'm going to end this part here, and we'll pick up on another video.